Welcome to the Corval Group Excavation Safety Training Module. The purpose of this training is to increase awareness to and mitigation of common hazards associated with performance of excavation activities. Included in this training module are facts about excavations, terms relating to excavation, OSHA regulations relating to excavations, and safe work practices that can protect you in an excavation. You will also be able to recognize common hazards that could cause an excavation incident or injury, as well as be able to identify workplace behaviors that could result in incident or injury at an excavation. You will hear the following terms throughout the training module: excavation, trench, spoils, cave-in, permit required confined space or PRCS, soil sample, and competent person. These terms will be defined on the following slides. Excavation: any man-made cut, cavity, trench, or depression in an earth surface formed by earth removal. Trench: a narrow excavation. In general, the depth is greater than the width, but the width of the trench is not greater than 15 feet, measured at the bottom. Spoils: materials being removed from the excavation. Cave-in: a sudden collapse or degrading of the excavation wall that results in material re-entering the excavation. Permit required confined space, PRCS. Contains or has the potential to contain a hazardous atmosphere. Contains a material that has the potential for engulfing the entrant. Has an internal configuration that might cause an entrant to be trapped or asphyxiated by inwardly converging walls, or by a floor that slopes downward and tapers to a smaller cross-section, or contains any other recognized serious safety or health hazards. Please note, not all excavations are a permit-required confined space, but there is a possibility that at some point an excavation may be considered a permit-required confined space. Soil sample: representative collection of materials, or soil, used to determine soil classification. Soil classification determines the protection system or systems that will be required for personnel to be allowed to enter the excavation. Class A, B, or C soil. Most excavations are classified as Type C soil, requiring at least a 1.5 to 1 sloping or 34-degree angle of incline. Competent person: an individual who is capable of identifying existing and predictable hazards or working conditions that are hazardous, unsanitary, or dangerous to workers, soil types and protective required systems, and who is authorized to take prompt corrective measures to eliminate these hazards and conditions. Locate the hazards associated with this excavating activity. Worker standing inside of excavation while heavy mobile equipment is working nearby and he is not wearing a high visibility vest. There is unstable and loose soil on the excavation wall, which could result in material sliding into workers below. The sloping or benching along the excavation walls is not sufficient for the types of soil being worked in. The spoil piles are not being kept a minimum of 2 feet away from the edge of the excavation. Excavations can be dangerous to work in and around. There are nearly 1,000 workers hurt each year by excavation cave-ins. 140 of the 1,000, or 14%, result in permanent disability. 38% of all excavation incidents are due to cave-ins. This is partly due to the fact that cave-ins tend to occur suddenly, leaving no time for people to react to the situation. The weight of soil depends heavily on the moisture content of the soil. Dry sandy soil weighs about 2,600 pounds. On average, 24 workers are killed each year in excavation collapses. Cave-ins are the biggest risk associated with excavation activities, but there are other risks to be aware of as well. Falls, falling loads, unidentified utilities, hazardous atmospheres, mobile equipment, struck by, caught between, crushed by, or property damage, water intrusion like rain, line breaks, or water table, and impalement hazards like rebar and fence posts. Excavating rules to live by. Before any excavating activity, be sure the underground utilities have been located. Contact the one-call services for the state being worked, and they will have the utilities within your worksite located. Identify other sources that may affect the stability of the proposed excavation site: buildings, building foundations, buried utilities, other nearby construction activities, nearby roadways, vibrating equipment, or the water table. Put on your high-visibility clothing prior to working near or around any large mobile equipment. Heavy equipment should not encroach upon the excavation edges, as this can cause sudden collapse of the excavation. Spoil piles are to be kept at least 2 feet back from excavation edges to prevent excavating materials from falling into the open excavation. Ladders being used in an excavation are to be used in the same respect as a ladder being used on a flat level surface above ground. Make sure you secure the top and bottom to prevent ladder movement. The ladder must extend 3 feet above the top of the excavation, and the ladder ratio of 4:1 is to be maintained. Extension ladders are not to be used as a walking plank, laying on the slope. Excavations are to be barricaded according to hazard potential: hard barriers, construction fencing, rope, warning or caution tape, flagging. An excavation left unattended and potentially accessible by other people needs to be appropriately signed and barricaded. All excavations 4 feet deep or greater require safe access and egress points: ladders, steps, and ramps. These access and egress points must be positioned so no worker would have to travel more than 25 feet to reach a point of access and/or egress. All employees and subcontractors are empowered, authorized, and obligated by the owners, president, and leadership of Corval Group to stop work at any time for any unsafe condition. All employees and subcontractors are expected to stop working until the hazard or risk has been resolved. The stop work authority can be difficult for employees to embrace because of the fear of losing their job. Be assured that no employee will ever be penalized for using stop work authority. One of the best ways to prevent excavation-related incidents and injuries is to inspect the excavation frequently. OSHA requires excavations to be inspected at the start of each shift prior to entry. Excavations are inspected more frequently depending on circumstances, such as rainstorms, other water intrusion, or any occurrence that could change conditions in the excavation. People are not permitted to enter or work in an excavation with standing or uncontrolled incoming water. As with all construction work, it is unacceptable to position yourself under a suspended load, like a pipe being lowered into an excavation. Impalement hazards are generally thought of as a hazard that is presented by elevated work activities. However, there are several circumstances during excavation activities that can create impalement hazards. Oftentimes, when putting rebar in for a foundation, there are exposed rebar points that could result in impalement if a person were to fall into the excavation. Other things can pose an impalement hazard in an excavation as well, such as wooden stakes, grounding rods, or fence posts. Impalement hazards need to be guarded as soon as possible to protect people from the possibility of impalement. Excavations 5 feet deep or greater require protection systems unless the excavation is made entirely in stable rock. Excavations 20 feet deep or greater require protective systems that are designed by a registered professional engineer, RPE, or be based on tabulated data prepared and/or approved by the RPE. There are multiple factors to consider when selecting a protection system. Depending on the depth, 5 feet deep or greater, soil types, and configuration of your excavation, there are different types of excavating protection systems that may have to be implemented. Some of the acceptable protection systems include benching, sloping, shoring, and shielding. Benching is a method of protecting people from cave-ins by excavating the sides of an excavation to form one or a series of horizontal levels or steps, usually with vertical or near vertical surfaces between levels. Benching cannot be done in Type C soil, like gravel or sand. Pictured is an example of a benched excavation. Sloping involves cutting back the excavation wall at an angle inclined away from the excavation. The angle of incline depends on the type of soil found in the excavation. There are 3 classes of soil. Type A is the most stable of soil types and generally comprises of clay, silty clay, clay loam, hard pan, or cemented soils. No soil will be considered Type A if the soil is fissured, subjected to vibration, was previously disturbed, is part of a sloped layered system like Type A soil on top of Type C soil sloping into the trench, or it has water seeping through. Type B is the second most stable soil type and is generally comprised of angular gravel like crushed rock, silt loam, previously disturbed soils unless otherwise classified as Type C soil, dry unstable rock, and some sloped layered systems. Type C is the least stable soil type and is generally comprised of gravel, sand and loamy sand, any submerged soil with freely seeping water, and any unclassified soil. If part of a multi-layer system like Type A on Type B on Type C, the soil must be classified on the basis of the soil classification of the weakest soil layer. Each layer may be classified individually if a more stable layer lies below a less stable layer. Shoring is designed to work in areas where benching or sloping is not possible. Shoring is used to prevent soil from shifting by applying outward pressure through the shoring materials against the excavation walls. Therefore, it can be very effective when working in a shallow excavation that has vertical walls. The picture on the left is an example of vertical shoring. The supports in a vertical shoring system run vertically along the excavation wall. The picture on the right is an example of horizontal shoring. The supports in a horizontal shoring system run horizontally along the excavation wall. Shielding protective systems are designed to protect workers by using trench boxes or other types of supports to prevent soil cave-ins. Designing a protective system can be complex because you must consider many factors: soil classification, depth of cut, water content of soil, changes caused by weather or climate, surcharge loads like spoil or other materials to be used in the excavation, and other operations in the vicinity. Trench boxes are an example of shielding protective systems. Trench boxes must extend at least 18 inches above the excavation slope. Fall hazards are still capable of being present when working around an excavation. A trench box can sometimes pose a fall hazard. This is because the distance from the top of the trench box to the bottom of the excavation may be over 6 feet. Guardrail systems may be necessary to prevent people from falling into the trench box. Trench boxes need to have a form of ingress and egress. If it is infeasible to have an extension ladder as your means of ingress and egress into a trench box, it is possible to have fixed ladders installed. Fixed ladders and guardrails can be seen in the photo. Unprotected excavations are dangerous, and as a Corval employee or a subcontractor, you have the right to stop work and remedy the situation before beginning work. Remember, Corval Group will always support a subcontractor's or an employee's right to exercise their stop work authority. The basic flow of tasks before work can begin in an excavation is as follows. Identify the work area. Identify hazards associated with the area you will be working, as well as the hazards associated with the task you will be completing. This is the Task Hazard Analysis, or THA. Use a checklist to identify the hazards. This is the excavation checklist, and it is to be completed by the competent person. If any hazards are identified while completing the THA or the excavation checklist, the work must not begin until all hazards are conveyed to supervisors and mitigated. A competent person is required to inspect excavations each shift before workers are allowed to enter the excavation. The competent person is also responsible for identifying changes to the integrity of the excavation as work progresses. The competent person is responsible for stopping work should a change be identified that could affect the workers inside the excavation. If anyone feels the excavation they are working in is unsafe, they have the right and responsibility to stop work and alert their supervisor of the potentially hazardous condition. Stop work authority will always be supported should it be used on a Corval job site. As a side note, if you see someone use stop work authority, it may be worth taking the time to write a spot on them, because they may have just prevented an incident or injury. How can the Task Hazard Analysis, or THA, help prepare you? The THA, Task Hazard Analysis, is one tool to assist in identifying the hazards associated with your task before work begins. The THA is to be completed for all tasks, and when an excavation is to be entered, the excavation checklist should be completed as well. The top is an expanded view of the detailed job description section of the THA. In this area, be sure to include all tasks that will take place throughout the workday. Update the THA as new tasks and/or hazards arise. The bottom is an expanded view of the environment section of the THA. The atmosphere inside of an excavation must be monitored for hazardous gases if the potential for a hazardous atmosphere exists. The top is an expanded view of the walking and working surface section of the THA. Use this section to evaluate the excavation for loose soil and other materials that may be able to fall and/or roll into the excavation and may become a trip hazard. The bottom is an expanded view of the work permit section of the THA. If a special permit is needed for an excavation, it is important to make sure it has been issued before work commences. The top is an expanded view of the confined space, excavation, flat roof work, and critical lifts section of the THA. If concerned about whether or not the excavation is a confined space, stop work, SWA, and talk to management. The bottom is an expanded view of the special precautions section of the THA. Include special concerns in this area, like water present, weather, shoring conditions, or loose soil. The top is an expanded view of the Emphasis 1, line of fire and pinch points. In this section, it is important to identify pinch points associated with the tools, materials, and equipment that will be used during all job steps. The bottom is an expanded view of the Emphasis 2, eye injury hazards section of the THA. In this section, it is important to identify eye injury hazards that may be present within the job steps, like sparks, blowing dirt, and/or debris. An excavation checklist will help the competent person assess an excavation. The excavation checklist is to be completed by the competent person. Any hazards that are identified during the inspection need to be documented on the checklist as well as the THA. The hazards need to be communicated with the foreman and those responsible for maintaining the excavation. The excavation checklist is to be completed prior to entry into an excavation. Should an item be marked as a no, work cannot begin until the situation or hazard has been mitigated. An excavation checklist is a tool that will be used in conjunction with the THA to help protect people from the hazards of working in an excavation. When done together, the THA and the checklist will help you to identify hazards before you encounter them, giving you time to mitigate those hazards. Answer the following questions. True or false? Because excavations are outdoors, it is not necessary to be concerned about hazardous air. The outdoor air will neutralize any bad air in the excavation. False. When dusts, fumes, mists, vapors, or gases are produced, they must be handled to prevent a hazardous atmosphere in the excavation. True or false? If you are working in an excavation where there are only a few inches of water, you are permitted to work in the excavation. False. Employees shall not work in an excavation where water is standing or accumulating. True or false? If an excavation needs a ramp for entering and exiting, anyone on the construction crew can be assigned to find a ramp and put it in place. False. Structural ramps at excavations must be designed by a competent person and constructed in accordance with the design. True or false? When a construction crew digs for an excavation, it is okay to pile the dirt that is dug up, the spoils, right at the edge of the excavation. False. The spoils of an excavation must be kept at least 2 feet from the edge of the excavation. This could be more stringent based off of the client's own policies. True or false? A competent person has the authority to evacuate an excavation site if that person believes the site is exposing employees to unsafe conditions, such as a possible cave-in or hazardous air. True. The competent person has authority to evacuate an excavation site if it is exposing employees to unsafe conditions such as a possible cave-in or hazardous air. Locate the hazards with this excavation. There are multiple problems surrounding this ladder. The ladder is poorly made. The ladder does not extend at least 3 feet above the top of the excavation. Housekeeping is lacking as they have materials at the base of the ladder and falling into the excavation. This area shows a couple more hazards. The excavation appears to be over 5 feet deep, which means it would need a protective system in place: sloping, shoring, benching, or shielding. There is no protective barrier to protect people from falling into the excavation. Locate the hazards with this excavation. Water is accumulating at the base of the excavation. Water is continuing to run into the excavation, and the benching is starting to collapse along the bottom row. With running water, the soil could be classified as Type C soil, and if it were classified as Type C soil, it would need to be sloped, because it is unacceptable to bench Type C soil. Locate the hazards with this excavation. There are gaps between the 2 trench boxes. It is unacceptable to have spaces between trench boxes, unless each trench box has its own access and egress point. You can also see that neither of these trench boxes extend the 18-inch minimum above the excavation wall. The trench box has been severely damaged in the top corner, and the spoil piles are not kept the 2-foot minimum away from the excavation. A large hole with no sloping is present, and there is no barrier in place to protect workers from being able to fall into the excavation. There are materials staged next to this hole, and they could fall into the excavation. Locate the hazards with this excavation. The ladder they are using is not secured at the top. It is also not maintaining the 4-to-1 ratio required when using an extension ladder. The worker is straddling the gap between the trench box and the solid ground, and he is exposing himself to a fall greater than 6 feet. It may be hard to see, but there are 2 workers inside of the trench box, and one of them has positioned himself under the load. They have removed the trench box spreader supports on the far side of the trench box. The worker is not wearing safety glasses or a high visibility vest. Working in and around excavations can be hazardous, but with the proper training, preparation, and planning, the task can be done without incident or injury. The safety of all Corval employees and subcontractors is of the utmost importance. Ask if unsure of your tasks or what the safety measures are necessary for your task. Complete all required forms: THA, excavation checklist, equipment checklists. Follow all safety rules and regulations. And remember, stop work if you feel your safety or the safety of others could become compromised. Thank you for participating in the Corval Group Just-in-Time Training Module. Contact your regional safety manager with questions, comments, or concerns.